Hi, the second test in 3.2, a test by difference in deviances. So now that we compare a smaller model and a larger model. So smaller model here is just the null model, kind of null model. So eta is equal to beta naught, and the H1 is eta is equal to beta naught plus beta 1 x. So in general, that we can set any model, but just at least the H1 should nest H0. So that is the only condition. So maybe H0 have 2 variables, 2 predictors, and H1 may have 5 predictors. Then difference is 3 predictors, so that's fine. So just in this specific example that we have this H0 and this H1. Then we think about the difference between deviance. So difference between 2 deviances. So as we have seen in the previous video, the null deviance for the H0 is the 38 or something, right? And the second one is 16 point something, right? So the difference is 22, 21.98538. So this is the chi-square statistic. And the difference between these two models is just one parameter. So df difference in degrees of freedom is 1. So difference in degrees of freedom is 1. So this follows chi-square distribution with df1. So chi-square of 1. So obviously, so this 21.9 is very large. Chi-square 1 distribution expectation is 1. So that is just, you know, chi-square 1 is the squared standard normal distribution. So obviously, it's very large and it's significantly different. But okay, so we calculate with this p chi-square function. Then the difference in deviance, the 21.98 and the df1, and we calculate the upper tail probability. So again, we have the chi-square distribution with df1. So chi-square df1 has this kind of density. So if so 1 is maybe around here, and our difference in deviance is 2.74 times 10 to the power negative 6. So it's very small. So this is p-value. And this is very small, so we reject null hypothesis. So we can test, and we rejected the null hypothesis. So another way is to focus on this beta 1. If beta 1 is significant, then H0 should be rejected. So that is another way. And that p-value was given by this. So you can go back to the original output and you can see the p-value for temperature. So this is the p-value for beta 1 hat. So that is 4.78 times the 10 to the power negative 5. So this is highly significant. So we are not very happy that these two numbers are not different, not the same. Okay, that should be the same because we are testing the same thing. But basically, this happens because all logistic regression or binomial regression results are approximate. So basically, this is so-called likelihood ratio test, and asymptotically it converges to the chi-square distribution, but not exact for finite observations. So that's why these two are different. But anyway, both are highly significant.